Okay guys, today we are going to be looking at rational functions. So when you see the word rational, what is the word that you should see that jumps out at you?
Ratio.
Ratio. Okay, so it's something over something else. And so let's think about this. Like if I just say y is equal to 3x, is that a ratio? Is it? It's something over something? No. This is just a what? This would how would we describe this? What does this mean? It's an equation of what? A line. Jaden said line. Okay. And everybody else, you're right. I was looking for the word line. Okay, so that's not a rational function, it's just a line. How about, and be careful about this, what if I had y is equal to x over 3? That's what? That's still a what? Josie just said it. It's an equation of a line. Okay. Because the 3 is just like, that's a third, it's like the slope. Okay, so that hasn't changed anything. But where you get something different would be, what if you had y is equal to 3 over x? Now you have a what? Ratio, right? You've got a rational equation now because you have a variable in the denominator. And let me show you kind of how that would work. Let's say that you guys, the students, got together and decided to buy the coach a gift. So students will buy coach a watch. Okay, you're going to buy him a nice watch. What do you think a nice watch would cost? Well, oh, man. You're going to buy him a nice watch. $1,000? Okay. I was thinking like $150 for a watch, but you guys are going to buy your coach a watch for $1,000. Okay, now, so the students are going to buy the coach a watch for $1,000. How much should each student give in order to get him the $1,000 watch? What did you say?
How many are?
Yeah, you see, I asked a question that you didn't have enough information to answer, so then Tanner right off the bat ask me for the missing piece of information, and that is what? How many are there? Okay, but tell me, the cost each, so we would say, what would we call this? E for what each student should give is going to be equal to, like, let's set it up. It would be like, set up an equation.
1,000 over S.
Yeah, 1,000 over, and what did you say, S? Okay, and so E is, contribution from each student, and S is what? Number of students, right? Okay, so let's think about this. If I had the number of students, and then I had what each is going to have to give, just think about this. Like, what if you had 0 students? How much would he have to contribute? What?
0.
For 0 students?
0.
So 0 students could spend $0 and buy a $1,000 watch? No.
It'd be still 75.
It'd be what? 0 students?
Oh.
No, it'd be infinite, right?
Oh.
Because it would be 1,000 divided by what? And that's what? Undefined or infinite, right? And so you couldn't have 0, but if I had 1 student, what would it cost? Each would cost 1,000. If I had 4, it would be what?
250.
If I had 10, it would be what? If I had 100, it would be what?
210.
If I had 1,000, it would be what? 1. So let's look at this, okay? So let's go like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this would be like 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. Okay? And then I go 1, and this would be like, let's say, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90. So this would be like 5, 10, 15, 20. Okay, so if I had one student here, it'd be 1,000. And you see, if I had half a student, it would be 2,000. And if I had 5 students, it would be 200. Okay? If I had 4 students, it would be 250. If I had 10 students, it would be 100. If I had 20 students, it would be, what, 50. So do you see what the graph is doing? It's coming down, and it's coming, and then it's coming across. And the further I go, the closer and closer it gets to what? 0. Does it ever get to 0? No, it just gets closer and closer to 0. So like if I had 1 million kids, they would just have to pay a fraction of a penny. But always you would have to pay something. And then you can never go to 0 because it would explode. But you see how you end up with curves that look like this? That's a rational function. Does that make sense? Okay. So let's look at a rational function, and how do we graph a rational function? Well, first of all, we have to see where it's undefined. And where it's undefined, we have what is called a vertical asymptote. A vertical asymptote you can get closer and closer and closer to, but you can't actually touch it, because if you touch it, what happens? It explodes, because you're dividing by what?
0.
Right. Okay. So let's think of something. F of x is equal to x over x plus 3. Now, what I'm going to ask you is, where is the vertical asymptote? And don't tell me the answer. Tell me how you would get to it. The vertical asymptote would be... How's it going, sir? Braden. Okay, the vertical asymptote would be what?
-3.
Okay, you told me the answer. I'm glad that you can see it. But let's see how we get to it, because we want to see how we could always find the answer. The vertical asymptote is where what's where?
X is equal to 0 is in the denominator.
Okay, not where x is, where the what is what?
0 is in the bottom.
Not the bottom. 0 in the denominator, okay? So, the vertical asymptote is when what? X plus 3 equals what? 0. So, what I'm doing is I'm setting the denominator to
0.
Are we good? Okay. Braden, can I give you the homework here while you're...
Yeah.
Okay.
I'm just going to the bathroom.
All right. And then this is, he's recording so you can watch this online, right?
Yeah.
Okay, the homework is 13 through 16, 17 through 20, 58, 64, and the bonus is 56. Okay? So, we set to get the vertical asymptote, we have x plus 3 equals 0. So x is equal to what? Okay, this is the vertical asymptote. All right. So now if we were to graph this, what does the vertical asymptote look like? It's a dotted line where?
At -3.
Don't say at what is -3?
X equals.
At x equal -3. So you were seeing it in your mind, Levi. I just want you to say it right? So we put a dotted line here. So that means as we're graphing, you can't set anything to the vertical asymptote. But as I get closer and closer to the vertical asymptote, this thing is going to kind of be exploding, right? And so what you could do is like, well, what if I picked -2? Well, -2 plus 3 is 1, and so this would be -2. So at -2, it would be down here at -2. At -1, I have what? 2, and then I have -1/2, right? So what you would see is this one would look like this on this side, right? Do you see how that would work? Do I stop there, or do I have to do the other side? The other side. So let's say that I'm at minus 4. At minus 4, what's the denominator? Minus 1. And at minus 4, I would be minus 4 over minus 1. Okay. Minus 4 over minus 1, that's what? 4. So here, I'm up here at 4. And then if I'm at minus 5, okay, minus 5 would be minus 2, minus 5 halves, right? I mean, minus 5 over minus 2, that's 2.5. Okay? So you see this one would come up like this, and then like that. But do you see you've got to kind of plug in some values, and then you can see. But you always know it's either going to explode or explode by the vertical asymptote. Okay? So, you can have more than one vertical asymptote. You can have more than one vertical asymptote. So let's say, well, let's just do another one though. G of x is equal to 5 onto x minus 6. Josie, tell me how to find the vertical asymptote. Don't tell me the vertical asymptote, tell me how to find it.
Set the denominator equals 0.
Yes, and what is the denominator?
X minus 6.
X minus 6 equals 0, and therefore x equals 6 is the vertical asymptote. And I like it because she didn't tell me 6, she said set the denominator to 0. That is always how you find the vertical asymptote. So here the vertical asymptote would be 1, 2, 3, 4, 5, 6. It would be like that. Does that make sense? Okay, now let's think of another one. What if I had h of x is equal to x plus 4 over x minus 1 onto x plus 4. Okay, Kelsey, tell me how to find the vertical asymptote.
Set the denominator to 0.
Why am I happy? Because she told me how to do it, and that is always true. Okay, so you're going to say x minus 1 times x plus 4 equals 0. Now, Logan, talk me through that. Now, how do I find the vertical asymptotes? Now, like, it's this times this is equal to 0. How would you figure out, like...
Do you take the chunks apart and set both of them equal to 0?
Yes! There's two ways that this whole thing could be 0. One way would be if x minus 1 is what?
Equal to 0.
Okay, or?
X plus 4 equal to 0.
Okay, so I have x equals what?
1.
That's a what?
Vertical asymptote.
Is that the only one?
No.
What's the other one?
Negative 4.
X equal negative 4 is a vertical asymptote. Okay? And so on that one, you would have a vertical asymptote at 1, and you would have a vertical asymptote at negative 4. Now, we would have to plug in some values, right? It might like go like this, or it might go like this, or it might be like this, or it might be like this, or it might be like this, right? We would have to plug in some values to see what it looked like. But the key to success is to start by finding the what? The vertical asymptotes, okay? We start by finding the vertical asymptote. Okay, now this is, and so you guys, you see that you just plug in a few values, like you plug in some values here, and you see is it exploding up or down, and then you can kind of sketch it in just by plugging in some values, but you find the vertical asymptote. Okay, now this is an interesting one, and this is very, very, very important, because in the real world, like what would happen if you ended up dividing by 0 in the real world? What would happen? What? What?
In the real world, it would just be nothing.
Well, no. Buildings fall over, bridges collapse, things explode, things catch on fire. Disaster happens when you divide by 0. Like sometimes when you guys have written programs and you divide by 0, what happens? You get like an overflow or your program crashes. Well, what if that program was flying an airplane. What if you wrote a program that is flying an airplane and then your program divided by 0? What would happen to the program? It would crash. And then what would happen to the airplane?
It would also crash.
It would also crash. Okay, so that's why you have to be so careful and not divide by 0. All right. But now, what if I had f of x is equal to x plus 2 over x minus 1 over x plus 2? Okay. Now, what would you tell me to do?
Set the denominator to 0.
Well, not yet. I mean, what happens here?
Oh,
It makes 1. Why am I happy with what Jaden said?
She didn't say it cancels.
Yeah, she didn't say it cancels. She said it makes 1. So x plus 2 over x plus 2 is 1. So I have f of x equals x minus 1. Okay. But this is what you have to see. I don't have a vertical asymptote, but even though I took the x plus 2 out, I have to put a hole there. And what that means is you have to, when you take this out, you have to still say x cannot be equal to what? Negative 2. You see that? Even though the x plus 2 went away, it's really still there. So you cannot ever let x equal negative 2. Does that make sense? So how would I graph this? Okay. Well, all right. First thing I do is what before I graph it?
Vertical.
Well, even before that, though, I simplify it, right? And now, what is this the equation of? A what? Okay, and what's the y-intercept? Negative 1. And what is the slope? 1. Okay. So my line is like this, okay? But what have I got to make sure not to forget? So how do I show on the graph that x cannot be negative 2? Well, what you do is a dotted line would be a vertical, I didn't get that in the right spot. Let's put it right. This is negative 2 here. You put an open circle. So that means you could get infinitely close to negative 2 on either side, but you can't make it negative 2. Now, why is it an open circle? Because is it exploding as I get close to negative 2? No, it behaves perfectly. But I just can't be at negative 2. Now, if that had stayed in, if x plus 2 had stayed in the denominator, I wouldn't have a hole. I would have a what? Vertical asymptote, right? I'd have a vertical asymptote.
Teacher,
So,
pardon the interruption, but if you have not checked your row and sent it in yet, could you please do so? Thank you.
thought I had. Didn't I already do it?
Did you do that on that computer?
No.
Yes. Yes. Did you get it on this one? Who's coming in?
Okay. Does that make sense? So, if you take out a term in the denominator, it leaves a what in the graph? A hole. If it stays in there, you're dealing with a what? Vertical asymptote. Okay. So let's see if we can kind of figure out what we're dealing with here in this way. Okay, so I'll give you a problem. If I have f of x equal x squared minus 1 over x squared minus 6x plus 5, Kelsey, how would you look at this? How would you tell me how to deal with this? Like if you were just going to try something, what do you think maybe we would need to do here?
Try to factor it.
Factor! Boom! Yeah. Can I factor the numerator?
Yes.
It's a what?
Difference of groups.
Okay, so I'm going to have what?
X plus 1, x minus
x minus 1, x plus 1. Okay? Levi, can I factor this?
Yes.
Okay. What goes here and here? X and x. Are the signs the same or different? They're the same. Are they plus or minus? Minus. Okay. What's a way that I can get to 5?
3 and 2.
Ah, no, you've got to multiply. 5 and 1.
1 and 5.
Okay. So now this is x squared minus 5x minus x is minus 6x plus 5. Boom. All right. Now, what is something that I'm going to end up with? Like, Jaden, what do I do now?
We tried to simplify.
Okay, is there anything that I can do? What's that?
X minus 1 and x minus 1 is 1.
Yeah, x minus 1 over x minus 1 makes 1. And so I have what? X plus 5, or x plus 1 over what?
X minus 1.
X minus 5, right? And when I do that, what do I have to write down right now?
X not equal plus 1.
X cannot equal 1. All right? Is that a vertical asymptote or a hole? That's a hole. But now, am I going to have a vertical asymptote? Where? When what?
Negative 5.
No, don't give me the answer. When what?
Plus 1.
X minus
X.
5 equals 0.
X minus 5 equals 0. And why? Because when you just tried to give me the answer, you gave me the wrong answer. Which I'm glad you did. Because it shows that don't give me the answer, give me the step. And the step is what?
X minus 5 equals 0.
And then it's clear that x is equal to what?
Negative 5.
X is equal to 5. Okay. So, in this case, I have a what and a what, Josie?
Have a vertical asymptote
What's it called? A hole. Okay. So where is the hole, Josie?
and 1.
Okay, at x equal 1.
X,
And where is the vertical asymptote?
X equal 5.
Very good. Very good. Okay. So those are called discontinuities. So we found our discontinuities. Okay. So that's very good. So you see how that works. All right. Let's see. Let's go ahead here and now I'll do one example where we go ahead and graph it. Okay, we'll go ahead and graph it. All right, so I have f of x equal x over x minus 2. Okay, Kelsey, tell me how you would start this problem. What would you do?
Set the denominator equals 0.
Yeah, to find your what?
Vertical asymptote.
Okay, and that's exactly right. Now what you probably did but didn't say out loud, you probably saw before you did that, is there anything I can factor, right? And when you looked at it, you saw there's nothing that can be factored, so you say, okay, I can't factor or simplify it, so I'm going to find the vertical asymptote. And the vertical asymptote, I said x minus 2 equals 0, so x is equal to, and that is your vertical asymptote is at x equal 2. So as I'm graphing here, I'm going to have 1, 2, 3, 4, 1, 2, 3, 4. It's hard to graph good on the board. I wish I had a nice piece of graph paper up here. Okay, and so what I know is I have a dotted line at x equal 2. And I know I can't go there. So what would be a good, I got to do that better. I didn't do that very good. What would be a better, or what would be a good point for me to put in? Because I got to kind of see how this is going to go. I can't put in 2, so maybe I should put in what? 3. So 3 over 3 minus 1 would be what? 3 over 3 minus 1 would be 3. So at 3, I'm at 1, 2, 3. Okay,
Why is it
and
minus?
Isn't it 3
Isn't
over
it
3 minus 2?
Yeah.
Minus
Okay.
2 and the answer is 1.
okay, 3. Oh no, wait a minute. Let's do it. All right. So x is what?
3.
3 over 3 minus 2 is equal to what?
3 over 1.
3 over 1, which is 3. Okay, we good? So here it's 3. What would be another one for me to try? 4? What happens at 4? That's 4 over
4 minus 2.
2 is equal to 2. So I'm coming down. Okay? How about if I went to 6? At 6, I'm 6 over 4. That's like 3/2. Okay, so, and then if I went to 3.5, you can see that it gets bigger. So do you see that it's going to go like that? Never touching 0 and never touching the vertical asymptote. Do you see what it looks like? It looks like that. Does that make sense? Am I done? No. What do I have to look at?
1.
Yeah, because it might go like this, or it might go like this. So let's look at the other side, which Logan suggested. Let's look at 1. Okay, so at 1, I'm 1 over minus 1. What am I? Minus 1. So at 1, I'm at minus 1. Okay, and then let's say if I'm at 0, I'm 0 over minus 2. I'm at, let's see, what did I do there? Okay, let's go minus 1. Right, minus 1 over minus 3. Is that good? Minus 1 over minus 3 is what?
1/3.
Is what?
1/3.
Okay, it's 1/3. You know what? We messed this up. You know what? We messed this up. Okay? We need to do this again because we didn't put enough points in, and that's what caused the problem. All right, so back up. I got in a hurry. Let's make a table. X and f of x. Okay? Now, where is my vertical asymptote?
Listen.
My vertical asymptote is where?
2.
2. Okay. Now, this is what you need to see. Besides a vertical asymptote, there's also a what? Horizontal asymptote. How do you get the horizontal asymptote? You think of a very large x. You think of a very large x, and then we're going to say the horizontal asymptote is equal to. So what if x was 1,000,000? If x was 1,000,000, what wouldn't matter? You wouldn't even see the what? The -2. So it would be like a what over a what?
A 1 over
1,000,000 over 1,000,000 makes what?
1.
1. So the horizontal asymptote is at what? Y equals what? 1. Okay. What if I had y is equal to 3x over 2x plus 10? Now to find the horizontal asymptote, I imagine that x is what? What?
1,000,000.
1,000,000. Josie, it looks like you have a question.
Jaden was asking if it said think of very high or very low.
Very, very high number, like a bazillion. Okay? A bazillion. So Jaden, if I had x was a bazillion, what number would not matter?
Plus
There's 3 numbers. Which number wouldn't matter if I put in a bazillion for x?
10.
The plus 10. Okay. The 2 matters because you got a bazillion, now you got 2 bazillion. The 2 matters. The 10 doesn't. So this would be like y is equal to like what over what? Like 3 bazillion over 2 bazillion, and that would be what? 3 over 2. So the horizontal asymptote is 3 over 2. Does that make sense? Vertical asymptote, I do what? I set the what to what? Denominator to 0. Horizontal asymptote, I do what?
Think of x as a very
Yeah,
high
think of x being a bazillion. And then the numbers that are added don't matter, but the numbers that are multiplied to it do. Okay? So the problem that we had is, in this problem, we didn't think about what the vertical or what the horizontal asymptote was. We put in a bazillion, and we know that the horizontal asymptote is y is equal to 1. And so where I messed up is I got to see that it's like this. Okay, then when you put the numbers in, you're going to find it was like this. And you know, I made it go to 0 without seeing that really it's going to go to 1. Now let's do this. Okay, so if we're at minus 1, x equals minus 1, that would be minus 1 over minus 3. Is that right? Am I right? And that is what?
Negative
1/3. So if I am at negative 1, right here, I'm at 1/3. What if I'm at 0? I'm at 0. What if I'm at 1? That would be 1 over minus 1, right? And that would be minus 1. So do you see this one is going like this? Does everybody see that?
Yes, sir.
Most of the time the horizontal asymptote is 0, but you always got to check because on a problem like this the horizontal asymptote was 1. All right? So let's do one more, okay? Let's do one more. So I'm going to say, I want you to graph f of x is equal to x squared minus 9 over x plus 3. Josie, in this case, tell me the first thing that you want me to do.
Factor x squared minus 9.
Boom. Right? And what is x squared minus 9? We call that a what?
Difference of perfect squares.
Difference of perfect squares. And so that's going to be x minus
3
and x,
plus 3.
okay, over x plus 3. Jaden, what's going to happen?
X plus 3 over x plus 3 makes 1.
Boom. Makes 1. And I'm left with what?
X minus 3.
And I better make sure to do what right here, Mario?
Include the x cannot be equal to
Negative 3. And what is that? Tell me what that is. That's a what?
a whole.
A whole. Okay. So that means then the graph is going to be basically a what, Mario?
A line.
Okay. The intercept is what?
Negative 3.
Negative 3. And the slope is what?
1.
Okay, so it's going to be like that, right? And then I got to put the whole where?
X equals negative 3.
Like that. Boom. You're done. Homework is 13 through 16, 17 through 20, 58 through 64, and the bonus is 56. Okay.